So based on the last session we had, at the very end, we were talking about firewalls. I was going to ask all of you to use the reaction button. Everybody has a reaction button on their Zoom screen, correct?
Yeah.
Okay.
Yeah.
So I want you to use the crying emoji, the face with the crying and the tears, to indicate no, bad. And I want you to use the thumbs up emoji or the applause emoji to respond to the following question on screen, okay? So I need everybody to click one of two buttons. There are 9 students in session, and I'm not going to display your answers to anybody else, but I just want to check to make sure that some really important points about Firewall stuck with our last session. So the first question is yes, true, thumbs up, or no, false, cry, cry, cry. Firewalls can be configured to protect with outbound traffic. Let me repeat the question. Firewalls can be configured to provide protection where outbound traffic is concerned. And I only saw one thumbs up, and I'm seeing a true in the chat. That'll work. You can post something in chat. I see 2 more trues. Okay. Fourth true in chat. Survey says, yes, that is correct. You can use a firewall to protect and defend and filter outbound traffic. The sad part is people rarely ever configure firewalls to do that, right? So even though the capacity is there, the thing is, most people are just concerned with inbound. Okay, ready for the next question? Okay. Here's the next question. Firewalls can protect with inbound traffic when users click links to view outside resources. Firewalls can protect and filter inbound traffic when users are clicking links to view outside content, resources out on the internet. And I'm getting some responses. I do have some crying. I see some crying faces. I did see a thumbs up at first, but then that changed. Okay, the truth is, okay, are we ready? Let's share the screen. If a user clicks on a link to request a network connection, the firewall will open the port and allow inbound network data if the user initiates the connection. If the inside user initiates the connection with an outbound mouse click, basically what happens is that the user is saying to the firewall, okay, I want to see this. And the firewall goes, oh, this is on port 666. Okay. And it opens up port 666, which is another, how is 666 significant? Somebody tell me.
Mark of the devil.
Yes, it's the mark of the devil, and it's also known malicious exploits, right? So if something's coming in on 666, you're a sitting duck if the user clicks a link that pulls it down. Now, one thing that I wanted to share with you, any questions about what we just shared? It's just really important that of all the things that you learn in the network class, you learn how a firewall is good and how it's limited, right? So if you're supposed to go to a website, right? Let's say that you're supposed to go to a web server. Your firewall, right? Your firewall is much better than original firewalls. Original firewalls used to be very, very crude. And basically they would just filter all the ports, and then the users would have to know which ports to work. But modern firewalls, or latest generation, next generation firewalls, your Windows firewall, for example, right? Your Windows firewall is referred to as a stateful firewall, because if there's something that's there for web that's enabled, or file and print sharing that's enabled, it understands, okay, it's supposed to be TCP. Okay, it's supposed to be port 53 if it's DNS. If DNS requests are coming in from a different source, if DNS requests are coming in on a different port, or somebody's supposed to connect to a web server and it's not the advertised port 80, or email is coming across something other than port 25, the firewall is said to understand the state of the protocol. Oh, it's a simple mail transport protocol. That state requires port 25. Now, I'm oversimplifying, and some network experts are cringing a little bit, but I'm translating into plain English. When a firewall is stateful, it means it understands the correct state of a protocol or service. And if something is coming in and it's delivering email to a server other than port 25, then these firewalls with advanced security are smart enough to know, okay, something is really bad happening here. There is something really bad happening here, right? And that's what the term stateful means. So that's just one thing that we want you to understand about firewalls. Why are we spending an entire student learning objective in layer 4 and in layer 5 applications? Why are we spending quality time on this topic? Well, that's because much of the time, if you're having problems creating a socket, forming a connection, creating a session with a resource, it could be because the firewall is in the mix, right? So one of the things that I want you to understand is that it's not recommended you do this, but one thing you can do if you're troubleshooting your network connection, you can temporarily, and I mean like 30 seconds, 60 seconds, turn your firewall off. And when you turn your firewall off, it's going to fuss at you. It's going to say, hey, turn on your Windows firewall. But what I want you to understand is that if suddenly the error you're getting for your network application disappears, that's a sure sign that there's some interaction with the firewall that requires a rule. So you create a rule to allow an application through, or a specific port through. And that's very helpful. You are not creating Armageddon by temporarily disabling your firewall unless you leave it that way. Now, remember that an outsider is going to request a connection, and it's still up to the application to form the session. It's still up to the application to allow the connection. It's not up to the firewall. So even though the firewall is turned off, if an outsider is trying to get in, the thing you need to understand intuitively is that unless your application is written just plain stupid, and I'm sorry, but there are some coders out there that are just mindless when it comes to security. I'm going to say that again. There are budding software developers who are becoming professionals in their career path, and they're not really concerned about security on the network. And this is one of those times where I'm going to say, please, 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 if you find yourself years down the road, creating really cool network applications, I want you to remember this conversation we're having together. You're having with a 25-year veteran of network management. And what you're going to do is specify a specific port or specify, a specific control so that a firewall will know what and how to do with your software application, right? Yeah. So the firewall isn't going to stop. Usually the application will say, okay, somebody's trying to ask for this service. And if they're not asking if they don't have the right protocol, if they're not presenting the right attributes, the application, if well written enough, will simply refuse the connection without the firewall. That said, there's a lot of loosey-goosey, just make it work kind of apps that are out there circulating in the free apps store and, what is it, Google Play, right? There's all these forums, GitHub. Hey, I've got a neat network app that'll help your gaming go much faster, that'll help your network at your house run your internet will be much faster. And sometimes they compromise things to make stuff work better or faster. Just remember that how long have I been talking here with mine off? Like 2 minutes? Two minutes. I think it's okay between 30 seconds and 2 minutes for you to turn off the firewall, but before you leave the screen or shut your system down, you want to enable it again. Any questions about how not to blow yourself up with regard to firewall changes and using the firewall to troubleshoot problems with apps and transport layer? I can't form a session. I can't connect. I can't do TCP, UDP, no matter, right? This is where it really kind of hits the road. So one other thing I wanted to share with you about this too, it's kind of true, it's kind of cool. How many of you have seen this idea of network profiles? Can everybody see this right here where it says public network?
Yeah.
Okay, so my Wi-Fi connection in my home is a public Wi-Fi network, but you can modify the network to change the firewall profile that's used. So the firewall has in Windows, it has 3 different network profiles. One is public, one is private, one is workplace or domain. You might see the word domain. If it's in a corporate setting or a university, a large organization, a government agency, it might say domain network. So the stateful firewall in Windows is adapted to work differently if you're exposed to public network like Wi-Fi, which is always public, even in your home, because you're broadcasting with radio and it works like a hub, not a switch. I hope I'm talking to somebody here. Any Wi-Fi network by default is considered public, even if there are little padlocks and it's encrypted and you're using, AES encryption and all that happy hoo-ha. The simple fact is you're broadcasting with radio out on the open airwaves, and anybody with a good sniffer and the right equipment can see what you're doing. They can see the hidden SSID even. So remember that Wi-Fi networking is a lot like a hub. It's exposed, and whatever you put out there, everybody that's connected can see it. That's just how it is. Now, if I were connected with an Ethernet cord to my local router, it would say, oh, this is a private internal network, right? So it would say private network. If I were at the campus right now and connected, it might say domain network. Each of those network firewall profiles kick into gear when you are connecting. And when you connect to a network for the first time, it's going to say, hey, do you want others to discover your device? And the default, unfortunately, is highlighted for yes. And this is bad, 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 bad. Okay? Just plain bad. So if I were to connect to a different Wi-Fi right now, it would ask me, hey, do you want others to discover your device? And it would be highlighted yes. And most of us just hit enter. And that's a network security nuisance, which everybody should always click no, 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 no. So that's something we'll revisit in our final module, special topics, network security. But I just wanted, while we were talking about firewalls, I wanted to make mention of the 3 different profiles. Now you can also see the profiles that I'm talking about when you go into the Defender firewall and you look at the advanced settings and you look at inbound rules. Can everybody see here this column?
Yeah.
It says all. That means domain, private, and public. You can change a rule so that it's only private, right? You could say this rule only applies to a private network environment or a public network environment. See that? That's always considered public for Outlook or private for Edge. So you can change the profile and that changes the way that the stateful firewall rules apply and how aggressive it is when it's defending. So there is some intelligence or advanced security that is built in, and actually Windows Defender Firewall has come a very long way. So if any of you are convinced that you have to buy a commercial product to have a safe laptop, there is no software you can buy if your users are stupid and click on nasty links they're not supposed to click on. I'm just speaking truth to power, and I'm not judging, no judgment here. I mean, sometimes people click on a link and they think it's for a bunny at Easter time. And lo and behold, we all know this. Hackers love to embed things. You click on the cute bunny for Easter, and it's not a cute bunny for Easter. It's more like the rabbit bunny in a very famous movie called Monty Python's Holy Grail, something or other, when there was a killer rabbit, and the rabbit would, oh, anyway, I'm not going to go into that. Any questions about firewalls? This is, okay. So as intelligent or adaptive or advanced security a firewall may be, it's going to work in a predictable way, right? And so sometimes if you're creating an app or you're working, you'll find half the time that you'll have an issue. Now, one of the most common ports that's out there that hackers love is the SQL port. If you're connecting to a database server using a database application and you're working in MySQL, if you have the web applications course, CSC, what's the number for that course? 310? Web applications, right? Yeah. You'll have a course next semester or so that's called web applications, and you'll learn to work with databases on the server side, and on the front side, you'll build applications that access the database backend. You'll have to negotiate most commonly TCP port 1433. This is above the threshold of known ports, right? Because the known ports that are advertised are 0 through like 1054 or something like that. This is one of the exceptions. Now, we did give you other port numbers like 3389, and these are real specific, but a lot of times if you don't have a firewall rule added, then your junk won't work, right? And so you have to, what does that mean? When you're developing your software, you need to include code that will modify the firewall. And you've probably seen this. You install software or you start the software, and then a little pop-up shows that says, hey, this software wants to open a rule on the private network or public network. You know, do you want this? And most of us would answer, yes, I install the software. I know what it is. It's my printer software. I'm going to do that, right? Okay. So there is some really cool code that'll help you open ports on firewalls for Windows. You'll want to click the link in our study guide and our addendum. And if you find links that are broken, that don't work, and you report them to me first, I'll post additional credit. Okay? Any questions? All right, so there are 3 applications, network applications, that make the world work. It just works, okay? And one of the things that I wanted to share with you is to spread or to spend a little time in the 5th student learning objective. I wanted to talk about IP helper, DHCP, and DNS. Now, we've talked about DNS, and we're going to come at DNS a number of ways in many different contexts, in terms of security, in terms of a whole variety of things. But essentially, these 3 are like the 3 musketeers of client connection automation. So when you have devices that need network connections and it just needs to work, if you have one of these but not the other, if you have one of these but not the other, if you have one of these but not the other, what will happen is that your clients will only have part of what the network stack needs to function properly. Now, why am I going over this? Well, it's kind of like the firewall. Didn't I say, hey, if you're trying to create a network app or you're trying to work with a new app and there's connectivity in the mix and it's not working, not working, not working, what do you check? The firewall. What do you do to verify? You disable it for a few seconds, right? Everybody hear me?
Yeah.
Yeah.
On the most basic level, this is the first thing that you do, right? Because in our next module, in our final module, when I teach you how to build your first network app so you can just connect something on a network to exchange data, it's just plain cool. What I'm saying is you're not using well-known apps. You're just building your own, and you're putting it on whatever port you want. I mean, that's powerful, right? This is how the internet got started in the first place. Somebody did that the very first time for port 80 with HTML and HTTP. And now we have the World Wide Web. There's a whole consortium for that, right? So we're going to give you the tools to work that. First pit stop in troubleshooting is the firewall. Second pit stop are the 3 musketeers, or 3 stooges, if you will. Routers have a special service. It's called IP helper, or DHCP helper. This runs on a router. And what happens is that oftentimes you have local networks connected to local networks connected to local networks. And often the corner is a DHCP server that wants to help to give addresses, which include the gateway and the DNS, automatic assignment. Except that when somebody connects over here in the farthermost subnet in a network environment, maybe they don't pick up the DHCP assignment. Put another way, they get an address that starts with 169.254. And the first thing you realize is, oh man, I'm connected to a network that doesn't have a DHCP server. Seriously? I mean, my smartphone has a DHCP server built in. I can turn my smartphone into a hotspot and it runs DHCP. and automatically gives network addresses to other devices that want to connect to my smartphone, right? My hotspot device with my cellular provider, it runs DHCP. My wireless router runs DHCP. But I'm connected to a network that for some reason doesn't have it. If you see your network address starts with 169.254, it means, yeah, you're not talking to a DHCP server. Usually what happens is that the routers between those networks, you just built routes between different networks. But you can have a central DHCP server that works for all of those different networks. It can build a scope, what's called a scope, and serve all of those different networks if an IP helper is running in the background. When you connect to that network, the IP helper goes, oh, hey, you got to get an address from this DHCP. Hey, it's 2 hops over, right over here on the end of that network at UVI. See, if you have IP helper, it knows where to find the DHCP server. So the helper tells the client, this is where you get it. Then the DHCP establishes an IP address and tells the client, okay, here's where you get DNS, here's the gateway so you can get out on the internet, and so on. If you lack just one of these things, then your local network performance just doesn't, there's all sorts of hiccups, misfires, and strangeness. And what I'm telling you is that it may not be the code you're writing, it may not be the network application that you're creating that's the problem. It could be the basic logistics on the local network. So I want you to be aware of these three and how they interact with each other, right? Now, DHCP tells you, okay, this MAC address is on this IP address, and DNS says, okay, and this IP address relates to this named resource, right? So everybody gets to use and navigate a network based on names, which is what we do all the time. We don't even think about this, right? When we have problems with our network at UVI, or you have problems with your network at ISP with your internet service provider, 9 times out of 10, if it isn't the firewall mucking something up, it's one of these 3 services that's just sputtering or sparking. It's kind of like spark plugs or gas not flowing in a car. Does that make sense?
Yeah.
A car has to have something else besides the gas and the spark. It has to have air, or there's no explosion, right? Without air, if you don't have air in the mix, the gas doesn't light, it doesn't fire, even though there's a spark. So think of the combustion engine or the 3 Musketeers and make sure you understand this, right? Now, the DNS suffix, one of the things that's really cool to understand is that your DHCP can assign buku numbers of network criteria to any, it can even disable net BIOS. It can disable old protocols. It can basically make sure, it can say, hey, when you need to synchronize your time, go to this server out on the web. I mean, DHCP is amazing, it's underutilized. This is included in the DHCP that's running in your house. Any questions? Now, I'm going to embed a link here just to review kind of like the first piece of DNS and the second piece of DNS. There'd be like 3 or 4 minutes of YouTube, but you want to open the slides, especially slide 130, and it's talking about creating your own domain name. So you can own your own domain and have a web server and have your own email system with 1,000 mailboxes that each have 10 gigs of mailbox space and all that kind of stuff for just dollars a month. But you can create and reserve a domain name for like $10 a year or less, pennies a month, right? So you can do that on the public network. What we're going to do with your custom domain name assignment, I'm going to send you a schedule. I want you to tell me when you're available. we will choose a time together where we will share a screen. I will open up a DNS server and we will build, or you will build, your own domain on that DNS server. And then when you are finished, you'll be able to go to your browser and put in your name, the name you created, and your web server will come up on the screen. Okay. So I'm going to ask you to respond to a link to tell me when you're available this next week. You have to have the domain name in place for the first assignment in this module in order for us to be able to do that. So if you haven't done that yet, you really need to get that in. And but I'm going to assume that everybody has. And what I'll do is demonstrate on Monday, first thing. In fact, I'll even ask for a volunteer right now. If there is someone who would be willing to be the icebreaker, I will take your domain and we will demonstrate for the class how you can set up DNS so that from everywhere you sit, everybody can just open up their web browser and go to it, and there's their web server. Okay. Is anyone feeling brave enough right now to volunteer because you're proud of your domain name? And if you're not proud of your domain name, that's okay. We don't have to share it with the class. We can still do the solution, but I think it's cool to see all the different creative domain names that people come up with. No takers?
I have one.
Okay.
So do I just tell you it or?
Well, yeah, that would, if you're willing to do this on Monday, we can do this on Monday. And there's one other thing I want you to do. So the web server that's going to host your website, I want you to think of a catchy name that matches your domain name. And this is the thing I came up with here as an example. Let's suppose that I'm the first to claim marley.com. And my website server, the name of the website server is Bob, like Bob Marley, right?
Okay, okay.
Okay, so if you're going to go to the website, you're going to enter bob.marley.com. Now, we do something else with DNS where we substitute or create an alias for the server name because we don't want to put the server name out on the internet. We use www as an alias. So people go to www.marley.com and that's how the website comes up. But it's still good to have a name for the server, right? So I want everybody to think of, based on your domain name, what would you like to call your server name? Okay, right.
Okay.
Okay, so what is the name of your domain?
My hold on.
This is the one you submitted for the 4.1, right?
Yeah.
Okay. If you don't have it off the top of your head right now, that's okay. I can look it up. I'll be scoring credit for that submission for everybody first thing tomorrow morning and sending little nasty grams to any of you who haven't got a domain name in there yet. It's not complicated. Just think of something creative that has to do with you or your interests or, you know, something that matters to you. Okay. That's all we were going to cover for today. Based on the information presented, can any of you think of any interesting questions, or do any of you have any comments? Okay. Well, I hope you enjoy the weekend, and we'll see you Monday, and we'll kick off a demo of the solution and then keep right on rolling and finish. Thanks for joining us.
Oh wait, sorry,
Yeah.
Dr. Tento, before you go, I have a
Yes.
question. So, well, to clarify,